Hello everyone, I am Laxmi Durga. Firstly, I want to introduce my team members with you. My mentors are Ashwin sir and Arpit Yadav sir. My colleagues are Foram, Bharath, Surya. Now, I am telling about our project AIM. The project aims to give the idea of catalysis in modern era as they play a pivotal role in different industries. Details on catalyst design emphasizing and developing innovative ideas like nanomaterials, enzymes through which we can help further shaping the future of the industries as a chemical engineers. Now I am telling about our project research and progress. Firstly, we studied various research papers based on our project and we understood basic things related to our project. Briefly discussed about catalysis. Catalyst. The substance which enhances the rate of reaction is called as catalyst and the phenomena is called as catalysis. Catalysis is the backbone of many industrial processes which use chemical reactions to turn raw materials into useful products. Even the human body runs on catalyst. This is how the catalyst looks like. And here we explained the classification of catalysts. Catalysts are primarily categorized into four types. They are homogeneous catalyst, heterogeneous catalyst, heterogenized homogeneous catalyst, and biocatalyst. We will discuss briefly, and the first one is homogeneous catalyst. In homogeneous catalyst reaction, mixture and catalyst both are present in the same phase. It is common in either the liquid phase or gas phase. Operative temperature is generally low except only when it is under the high pressure. The recovery of homogeneous catalyst is complicated and exclusive. Homogeneous catalyst occurs basically in four steps. They are activation of catalyst, formation of reactive complex, reaction occurs, and regeneration of catalyst. Here is the example for the homogeneous catalyst. Here is the widely used example of homogeneous catalysis, Wilkinson catalyst, which is a homogeneous catalyst containing rhodium, facilitates the addition of hydrogen to an alkene molecule resulting in the formation of alkane. And the second one is heterogeneous catalyst. In heterogeneous catalysis, catalysts and the reactants will be in different phases. Those can be in three phases, which are solid, liquid, gas. Here we can see there are promoters and inhibitors. Substances called promoters enhance catalytic activity while inhibitors decrease the activity. These additives help in control catalytic process. Poisoning. Here substances absorb onto the catalyst surface reducing its activity. This can affect long-term performance. Here is the best example for the heterogeneous catalyst, which is a Ziegler-Natta reagent which is widely used in industries. It is a mixture of titanium chloride in its fourth state and triethyl aluminum in hydrocarbon solvent which is used for the polymerization of alkenes.
Biocatalysis. It is a substance which alters to mode the reaction. The substance, especially an enzyme, it initiates or modifies the rate of chemical reaction in a living body, and it is termed as a biocatalyst. Why do we need biocatalysis? Biocatalysts are currently employed for the production of products in different fields, such as pharmaceuticals or intermediate of their products as antibiotics, statins, fine chemicals, and food ingredients. Advantages. One of the main advantages of biocatalysis is its ability to highly selectively catalyze reaction under mild conditions. And here we can see the images of catalysis. Biocatalysts can be divided into six types. First one, isomerization. Second one, hydrolysis. Third one, oxidoreducates. Fourth one, lyases. Fifth one, transferses. Sixth one, ligases. Isomerization. It is a class of enzymes that catalyze reaction involving a structural rearrangement of molecular alanine racemase For example, catalyze the conversion of L-aniline into the isomerism form D-aniline. Further, isomers are classified into these 6 subclasses.
Oxidoreductase. Oxidoreductase enzyme catalyze oxidation reduction reaction. This is done by transferring electrons from one molecule to another. This group of enzymes usually utilizes NADH or NDA plus as cofactors. Reducing agent gets oxidized, oxidizing agent get reduced. These types of enzymes widely used in industrial reaction. Example such as dehydrogenases, oxidases, peroxidases. Transferences. Transferences enzyme catalyzes the transfer of functional group from one molecule to another. For example, amino methyl group and many more. Molecules give up the functional group is called donor and the molecule taking on the functional group is called acceptor. Example of transferences enzyme includes methyl transferences and amino transferences. Hydrolysis. Hydrolysis are types of enzymes that catalyzes the breakdown of large molecule into small ones through the addition of water. Hydrolytic enzymes are mostly commonly used in inorganic synthesis to produce the intermediate for pharmaceutical and pesticides. Example of the hydrolysis enzymes are phosphases, amidases, and esterases, and many more, etc. Lyases. Lyases are enzymes that catalyzes the cleavage of various chemical bonds by the method that is not hydrolysis, reduction, or oxidation. Often, lyases forming the reaction by the double bonds and ring structure. These types of lyases enzymes are found in cellular process, in organic synthesis, and critic acid cycle and production of cyanohydranes. Example of the lyases are decarboxylases. Ligases. It is an enzyme that catalyzes the joining of two molecules by forming a new chemical bond.
Recent developments which are going on in biocatalysis. So, in biochemistry, in DNA technology, in enzyme engineering, in bioinformatics, and we have recently faced the pandemic situation of COVID-19 also, in which biocatalysis and biopharmaceutical was at its peak. Then if I give you the example of biopharmaceuticals, then recombinant DNA technology, which is very effectively used for the curance of so many diseases like AIDS, cancer, then some disorders, diabetic patients for that also, then ulcer also. So for all that, biopharmaceuticals are still in research phase, and in COVID-19 also one drug, if I can remember, it's infliximab drug, which helped us for the curance of COVID-19 by so many researches in biopharmaceuticals. Other than that, you can see the image also. In chemotherapy also we use the enzyme also with the ligand together, and in cancer there are so many there are so many therapies which are used and for the curance of this big disease, cancer also. So here we would like to conclude with the future map of like modern catalysis research part, in which if we would like to tell you about the future plan, so we'll proceed with the development in current globe, like gene therapy for the genetics cure, then DNA technology, so and biometrics also. So AI biometrics will research in that also, and industrial biopharmaceuticals. And by the help of our mentor, we are genuinely excited to proceed by research initiatives. So thank you so much.